time since we just started the webinar. So once again, if you're just joining us, welcome. We will get started in just about 1 minute with Dr. McCarthy's seminar. Okay, so we will get started. It's great to welcome everyone to our second talk of the fall 2021 Cofrin Logan Center for Addiction Research and Treatment seminar series at the University of Kansas. I'm really thrilled to see a lot of people from our KU CLC family, but also a lot of names from places all over the country and even some other countries as well. And I think it just speaks to who our speaker is today and how interesting their work is. So I want to introduce our speaker in a moment, but also explain a little bit about how the webinar works today. For those of you that are joining us for you're back with another seminar, you know how this is going to work. But for those of you that are new, Dr. McCarthy will be presenting his talk and have slides and video. And a selection of attendees are listed as panelists, but everybody else will not have the ability to do video, just here to listen along. But if you do have video feed, please make sure you mute your microphone unless you're asking a question at the end. At the end of the talk, we do expect to have some time for questions. So this will be moderated by me. So the way this will work is if you have a question, you can either put it in the Q&A or send it to me as a chat message. And at the end, depending on how much time we have, we'll either ask you to unmute or I'll just ask the questions and we'll have Dr. McCarthy answer those. And unfortunately, with a lot of these things, we don't have time to get to every question. And I want to thank Sergey and Drew for, as always, their helpful coordination and logistical support for this. And I'm going to ask Sergey to also post links to our Twitter feed and our events page. You can learn about the rest of our activities that are happening this semester. And we have an excellent slate of speakers coming up in the spring as well, which will be posted probably in the next month or so. And now it is a very special and personal privilege for me today to introduce Dr. Dennis McCarthy. Dennis was my postdoc mentor at the University of Missouri, so we have a history of collaborating together. And Dennis is a professor in the Department of Psychological Sciences at the University of Missouri, where he directs the Alcohol Cognitions Lab. He received his PhD in clinical psychology from the University of Kentucky, and then went on for internship and postdoc at UCSD. And I just saw on his website, he's been at the faculty at Mizzou for nearly 20 years now. And has worked his way up to being the co-director of a very successful T32 training program there that I was a part of, as well as an R25 summer research program for undergraduate students, all focused on psychology of addictive behaviors. And his lab studies a lot of different things, but mostly focuses on cognitive factors that influence alcohol use disorder, addictive behaviors, alcohol-related risk-taking, such as drinking and driving. But I think really what sets him apart is he's a sought-after collaborator, mentor, and consultant for numerous students, postdocs, and early career faculty. And me personally, I credit him with helping me to write my first grant and also helping me to respond to my first critical letter to the editor, which I remember when I got that, I was like, how do I respond to this? And Dennis walked me through that process. So he's a phenomenal mentor, phenomenal researcher, and just a great colleague as well. So today, Dennis is going to be talking to us about acute alcohol effects and risk for alcohol use, alcohol-related consequences, focusing a lot on drinking and driving today. So Dennis, the floor is yours.
Okay, thank you for that introduction, Michael. It does say something about you that you got to postdoc before you got a really critical paper review. So that is a positive trajectory. So my talk today is going to be about acute alcohol effects and risk for alcohol consequences. I'm going to talk a little bit about some of the work I've been doing the last couple of years. I'm going to talk a little bit about lab work, EMA work, and decision modeling work. I want to just give a preface and say the lab work is, some of it's new, but some of it's a little dated. And the reason for that is because of the COVID-19 pandemic. We shut down our alcohol lab about a year ago. We did not reopen it yet. we were on the edge of it, and then Delta started. I just don't think it's really a safe environment yet for people to come in and blow into a breathalyzer 20 times in a small room with my staff. So we haven't been doing as much lab work, but luckily EMA is a pretty safe way of collecting data. So I'm going to emphasize some of that. And I'm one of those speakers that really thrives on the audience and the interaction of audience. So I'm going to pretend I'm interacting with you guys throughout this. Zoom has been a struggle for me for that reason. So let me get this started. So this is my alcohol is bad slide, right? We all have this. And it is. Societal costs for alcohol are huge. And a lot of those are biological, right? Liver disease and cancer. A lot of the costs are addiction. But what I'm going to talk about today is another big chunk of the cost of alcohol, and that is risky behavior due to intoxication. Bad or ill-informed or ill-advised behaviors that people are more likely to engage in when they're intoxicated. Alcohol-impaired driving is a major one, results in more than 10,000 deaths a year, and that's a big chunk of what I'm going to talk about today. But there are a lot of other risky or ill-informed behaviors that people engage in when they're intoxicated. And I think of my work over the last 10 or 15 years as the psychology of intoxication, understanding what happens when people drink, how it affects their decision-making, and how we might be able to disrupt that process so that people might not necessarily have to reduce their drinking, but can make better decisions when they do. My family members and friends that don't do this kind of work are always like, so you're studying what happens when you drink. I mean, don't people drink every day? Aren't there millions of episodes of intoxication that occur every day? And yes, there is. But to some extent, hopefully by the end of today, I'll convince you that there's an entire suite of things that we can learn from applying the scientific method to intoxication. One of the things that everybody knows, you probably know some people like this, that get a lot more impulsive when they're drunk, and it reduces, of course, their ability to control their behavior. What's important about that is that there are between and within person variability in that effect. Alcohol does increase impulsivity for most people, but some people get a much bigger spike in impulsivity or behavioral under control. And some people have more impairment in those processes on some occasions, some contexts, and in some circumstances. And so looking at that variability, both between and within person in the acute effects of alcohol, we can understand how the acute effects of alcohol increase risk for addiction and how they lead to problem behavior. So in my talk today, I'm going to start talking a little bit about how I got into this field, which is looking at decision-making and judgment in the lab. Then about 5 or 6 years ago, I started getting frustrated with the inferences that we can make from the lab, and technology had kind of caught up with the idea that we can study some of those same things and take some of the same hypotheses that we can test in the lab and study it in the natural environment. So I'll talk about a couple different studies that we're doing in that direction. And finally, in collaboration with my colleague, Clinton Davis Stover, I've also been applying kind of cutting edge decision models, mathematical models of decision making, and trying to see if we can learn new things that we don't get from more kind of traditional psychological methods. We can learn new things about the acute effects of intoxication, both in the lab and in the EMA. So I'm going to start with my lab research. And again, keep in mind that some of this is a little older because we're not collecting new data. One of the things that is interesting about alcohol-impaired driving is if you ask people if driving under intoxication, I use the term alcohol-impaired driving because I think drunk driving and drinking driving both are problematic in different ways. So really any impairment by alcohol makes driving a bad decision. But anyone you talk to today, right, we've done a very good job of messaging on this since the 80s. The perception of alcohol-impaired driving is overwhelmingly negative. There are a very small population of people who say it's not that dangerous to drive when you're drunk. So we all agree about that, but there's more than 4 million alcohol-impaired driving people that engage in alcohol-impaired driving every year. There's upwards of 120 million episodes of it, and 1.5 million people get arrested for alcohol-impaired driving every year. So not just that they engage in it, but they engage in it and they get arrested for it. We are losing about 10,000 people a year, or 1 every 50 minutes, to alcohol-impaired driving. So even though everyone knows that alcohol-impaired driving is a bad idea, this is still a lot of episodes. They're still engaging in this. A lot of people and a lot of episodes of alcohol-impaired driving happen every year. And some of my research is, why are people doing this if we know it's bad? Who are they and why did they do it? So one of the variables that I focus on is perceived risk. One of the reasons I like focusing on that variable, so perceptions of how dangerous it would be or the costs associated with the behavior, is it influences decision-making. It does predict behavior, but it's also one of the mechanisms we typically use to intervene in reducing behavior, right? A lot of the messaging around alcohol-impaired driving has been to convince people that it's dangerous, that you're likely to get caught. Even indirectly, the mechanism by which some things like random sobriety checkpoints are thought to exert their influence on alcohol-impaired driving is by increasing the perceived probability that you will get arrested or caught for alcohol-impaired driving, right? But at the same time, we know that, and this is how I got started in this field, I was like, well, everyone knows alcohol-impaired driving is bad, but they still do it. But I kind of don't care what people think about alcohol-impaired driving when they're sober. That's not the state in which they make that decision. So someone's saying it's a bad thing, don't do that. I'm interested in what they do when they're 6 or 7 drinks in, right? What's their judgment? How do they judge based on how they're feeling? And what is the role of their acute intoxication in that process, right? So one of the things I started with, Kim Fromme and I think Clayton Neighbors and several other people have documented that in general, acute intoxication reduces risk perceptions, right, for sexual behaviors or other acting out behaviors. I did a study that looked at this with alcohol-impaired driving, comparing people when they're sober and getting estimates of their perceptions of how dangerous it would be to drive after a certain number of drinks, and then getting them intoxicated and asking them the same questions, right? And we found a couple things in this study. One is a big effect of alcohol, right? So comparing their sober perceptions of how dangerous it would be to drive to their intoxicated perceptions, there was a big decrease in their perceived risk. But probably more importantly, is we saw that that effect was much more pronounced on the descending limb. And I want to credit my graduate student, David Morris, and my RAs that were working at this at the time. We matched people at the same BAC, sober, ascending, and descending. Right now, sober BAC is based on the hypothetical number of drinks and their weight and gender. That was a complicated process to get that for all the people, then to find the exact assessment during the alcohol administration that matched those. But we did find a big effect on the descending limb. And this made us start thinking about the role of acute tolerance. I think a lot of you probably know what acute tolerance is, but just a quick recap. We all know what chronic tolerance is. It's the adaptation of the body to the administration of a drug at a certain dose. Acute tolerance is changes in a single drinking episode. So to what extent does your body adapt to the presence of alcohol and reduce both your perception of intoxication and some level of impairment? So if you keep someone at the same BAC, how much does their perceived impairment and their actual impairment go down? There's differential recovery of subjective states of intoxication and their skills. And so in general, subjective intoxication is much lower on the descending limb. People then have a disconnect between their perceived impairment and their actual impairment, and their individual differences in the degree to which people manifest acute tolerance. So we were probing this idea. Well, actually, let me pull up the slide. This is a good graphical depiction of acute tolerance, right? As blood alcohol concentration changes across the ascending to descending limb, right? The actual drug effect, the difference between your blood alcohol concentration and the drug effect starts to diverge the longer the time goes on. This is the way that we measure it in the lab. It's very artificial, and I'll come back to this when we talk about the EMA, right? We dose people at the origin here, and so we give them a bolus dose of alcohol. They're ascending for about 45 minutes to an hour, depending on the dose. We test them at A, and then we test them again at B. So in this paradigm, we are testing them usually around 0.07, hopefully 0.08, but we don't always get that high because they actually have to go up to the peak, and there's a limit to how high the peak can be. And depending on the person, it might be 45 minutes to an hour later that they're back down at that same breath alcohol concentration. We test them again, we compare these two things. So one of the reasons acute tolerance is of importance to alcohol impaired driving is research showing when people make alcohol impaired driving decisions or when people get in fatal accidents. They're more likely to happen on the descending limb. So we get that information from, for example, drug tests, drug and alcohol tests from people who are in fatal accidents. They're clearly processing the alcohol and starting to descend. And just practically speaking, we know that people decide whether to drive home. They tend to do it more as they're starting to recover. This wouldn't be as huge a problem, except that Mark Fillmore at the University of Kentucky has done several studies now to show that driving skill is too complicated for it to recover and show an acute tolerance effect. So their judgments of their impairment go down, but their driving performance has not started to improve. Some individual components of driving performance have started to recover, for example, brake latency. But in general, their driving performance, their errors are about the same as they were at the same BAC earlier in the session. So this guy I knew once did this study, and he looked at perceived risk of alcohol impaired driving, right? So how dangerous do you think it would be to drive based on how you're feeling right now in the lab at matched BACs? And we found a huge acute tolerance effect, such that at the same BAC, this was around 0.076 or so, there was a huge effect that people saw themselves as as being less dangerous to drive while they were on the descending limb, even at the same BAC. We even saw some evidence for this effect in the placebo condition. Maybe a bit more concerning is when we asked people whether they would drive, right? So again, in the lab saying, based on how you're feeling right now, if we gave you your keys, would you do that? We're actually not allowed to do that. We're not allowed to give them their keys and let them start to walk out. I did ask the IRB. But we can ask them just their subjective evaluation of whether they would drive. A little less than 20% of people, again, around this 0.076 BAC, a little less than 20% of people said they would drive. And these are people that are in my lab. They're aware, I don't actually even try and pretend. They are aware that the study is about driving, right? And still almost 20% of them say, yeah, I would drive based on how I feel right now. I'm not that drunk. What's more concerning is that the same BAC, so again, just below the legal limit on the descending limb, 55% of people say they would drive, right? That's a huge effect. It's also a concerning percentage, right? The official position of the national, of NHTSA, National Highway Traffic Safety Administration, is that the legal limit should be 0.05. We haven't gotten there yet. It's still 0.08, but there's a huge reason to think that 0.076 is still quite impaired. So this is interesting, and it's studies that got me into this direction of looking at the acute effects of intoxication on drinking and driving decision-making. But one of the many problems of doing this in the lab is it's a pretty artificial situation, right? We're asking, would you drive right now? But situational factors really play an important role in the decision of whether you're going to drive home. Most importantly, how far it is, whether you have your car, availability of other resources or costs for getting home. So in the lab, we can't simulate a lot of those things. One of the things we did do recently is say, well, how much do people factor in driving distance, right? As someone that does a lot of this research and talks about impaired driving quite a bit, I know that people do this, right? I've had friends tell me, even knowing that I'm very anti-drinking and driving and very cautious about these things, I've had friends say, I'm going to have another drink because it's pretty straight shot home, or it's a pretty short drive home. I don't live very far, right? The law and your actual risk don't really care how far you're driving. But we know that to some extent, people integrate the distance and the complexity of the drive home. So one of the things we did was we tested whether people incorporate information about how far the drive is into their decision about whether they would drive at set BACs, and then whether that effect differed by limb. So this is relatively hot off the press. My current postdoc, Courtney Motchman, published this last year in Psychopharmacology. This is the relationship between their BAC and the maximum distance they would drive, right, as a function of limb. So on the ascending limb, there wasn't a big difference across different BACs. People were not willing to drive that far. But on the descending limb, people were willing to drive a certain distance, and that decreased as their BAC went up. So the relationship between how far they're willing to drive and their BAC was quite different and quite strong on the descending limb. We also found this when we look at their subjective intoxication. So remember, they don't know their BAC. We're measuring their BAC, but they don't know it. What they do know is how drunk they feel. And there was also a stronger effect in how drunk they felt and how far they were willing to drive, with people feeling relatively not drunk, being willing to drive 10 miles, whereas they felt more and more drunk. And again, most of these are taken at 0.07 or above. So not always at the above the legal limit, but pretty high BAC levels. Okay.
Hey, Dennis.
Yes.
We normally don't interrupt, but there's a really good question. Can you just define ascending versus descending limb for people that may not know what
thank you, Michael. Good point. So let me back up to this. So that's a good question. So we talk about this. I actually had a good conversation with Andrea King about this. We talk about there being an ascending and descending limb of the blood alcohol concentration curve. And what we mean is there's a period of time where your body is absorbing alcohol and increasing the amount of alcohol in your bloodstream. And then there's a period of time where you're eliminating alcohol and the amount of alcohol in your bloodstream is going down. In the lab, we dose someone with a certain amount, and the ascending limb lasts from 45 minutes to an hour. And that's my friends that do IV alcohol administration say, yeah, this is the slop of oral administration, right? Alcohol is not in your bloodstream when it's sitting in your stomach. It's not in your bloodstream if it's processed by the liver, but it gradually starts to get into your bloodstream after you get dosed, depending on how much you've eaten, how quick your body metabolizes food in your stomach, things like that. So the ascending limb is very variable, but it's as you're going up. The descending limb is relatively variable too, but it's pretty stable within person. People eliminate anywhere from 0.01 to 0.02 and change BAC per hour, right? Which doesn't sound like a big difference, but some people eliminate alcohol twice as fast as other people. And it's relatively stable. You can actually get better at it over time, but it's relatively stable. So this is what we talk about in the alcohol field, alcohol administration field, as ascending and descending limb of the blood alcohol concentration curve. The problem with this, and I'll talk about this when we get to the EMA part, is nobody drinks like this, right? I'm not saying that people don't give themselves a bolus dose of alcohol like we give them. We give them a lot of alcohol and they take a lot of it, but they don't give themselves a bolus dose of alcohol and then sit there for several hours afterwards, right? So this curve looks really neat, but it's pretty artificial. And there's a question as to whether this shape is ever actually obtained in any reasonable fashion in actual drinking events, right? People who drink, even if you drink a bolus dose, you're going to keep drinking a little bit as the night goes on. So the only thing that's real here, right? There is an absorption period, right? But the thing that's real is the descending line. At some point, you stop drinking and your blood alcohol concentration starts going down. But it doesn't always look like this nice bell-shaped curve. And the conversation I had with Andrea King was, as psychologists, we're very interested in the descending limb, and I'm talking a lot about the descending limb. But there's some question as to how psychologically relevant that limb is. How much of the descending limb are people awake for, right? When people are out in a regular drinking event, how long do they stay awake after they stop drinking to experience psychologically the full descending limb of the blood alcohol curve? I'll talk about that a little bit when I get to EMA. So hopefully that was helpful. I'm sorry that I did not make that clear. So just to wrap up the lab part, this is one way that we can look at situational factors in the lab. So just through a hypothetical question about how far they would drive. And the findings are pretty interesting in that people would say, well, I'm not safe to drive, but I'm safe enough to drive if it's short, right? Pretty much exactly what you kind of observe from friends who say, I'm going to drink a little bit more because it's a short drive. So there's a trade-off in terms of how drunk you feel, your willingness to drive, and how far you have to drive in a way that's not appropriate, right? But I like this study because it also kind of shows the limitations of contextual probing that we can do in the lab, right? So frustrations with that is what got me into EMA. And with my colleague Tim Truel here at the University of Missouri, we started thinking about ways that we can test some of these same hypotheses, but use EMA. Tim is an EMA, or Ecological Momentary Assessment expert. Ambulatory assessment is another term for that. where you actually collect data from people in their natural drinking environment, either through smartphones or other devices. And really, this is where the rubber meets the road in terms of understanding real drinking and driving decisions. So what I propose and what I'm kind of in the middle of right now is a study, excuse me, using mobile devices, mostly smartphone devices, to collect data from individuals, both self-report data. We can also collect some task data. Nice thing about smartphones is they also tell us where the person is, right? So it basically records their GPS whenever they're answering things. And one of the things that we did working with the computer scientists here at the University of Missouri is integrated a portable breathalyzer into the assessment. So we asked them questions, but one of the question types is blow in the breathalyzer, right? So this is an example of the Backtrack Pro. Actually, just Hank Kranzler's group just had a paper out in ACER recently showing that this is the closest mobile device to evidentiary standards. It outperformed all the others, and it's reasonably good if you get it calibrated relatively regularly. For research purposes, it's about $80. The thing that I like about my study, and I'll talk a little bit about this, is we were able to integrate this with our ecological momentary assessment platform, not using the off-the-shelf app that comes with the device, right? And I'll talk a little bit about that in a second. The nice thing about this design is it lets us assess drinking, not just how much they say they drank, but also their obtained BAC in real time to test some of the same hypotheses we've been talking about, but then opens up entire new avenues in terms of looking at actual contexts and how they moderate some of these processes. But as I was writing the grant to study this, I realized that the protocol was going to ask people about driving a lot. It was going to ask people about driving in the morning. It was going to ask them about their planned drinking. It was going to ask them multiple times during a drinking episode, hey, you're drinking. Have you thought about how you're going to get home? Hey, would you drive based on how you feel right now? How bad do you think that would be? Oh, blow in a breathalyzer. And I started to wonder whether that might disrupt the process I'm trying to study, right? To some extent, would asking people to think and reflect about their drinking and driving decisions alter those decisions, right? Which people in the ecological momentary assessment world call ecological momentary interventions, right? Can we deliver an intervention to get people to think twice about getting behind the wheel based on the questions we're asking and just having that time to reflect? So, but there's a tension between those two. If I'm trying to study a process, I don't want to disrupt it. And it took me a while to really get my head around the best way to do this, because I want that information, but I also would really like if we could reduce drinking and driving and change people's decision-making about this. So the design of the study is a multi-baseline crossover design. There is a 12-week protocol where people are answering questions on their phone for 6 weeks using EMA. That's a long time. Those of you who are familiar with EMA work, it's a long time to be in an EMA study, but we're trying to capture as many drinking episodes as we can. We keep our protocol as kind of trim as we can in order to make that feasible. We have a control condition where we don't ask a lot about driving, and we have 2 experimental conditions that vary in their baseline so that we can actually look at the effect of the onset and the offset of the ecological momentary assessment. We have a timeline follow back tailored to drinking and driving as a comparative assessment. And so that's the general design. In our first 48 participants, we just did 2 weeks of EMA just to test this out. We published this in Journal of Studies on Alcohol and Drugs last year, I believe. In just those 2 weeks, we got a relatively high drinking sample. We had over 1,300 evening reports. 250 of them or so were drinking. About 20% of our evening reports involved alcohol. We looked at their in-the-moment BAC, their subjective intoxication, and their perceived danger of drinking and driving, as well as their baseline perceived danger of drinking and driving. And what we found in this study was BAC predicted their willingness to drive. When they said, would you drive based on how you feel right now? BAC was a pretty solid predictor of that, right? Which is good. It should be predictive of that, such that the higher their BAC, the less they were likely to say they were willing to drive. But much bigger predictor was their subjective evaluation of intoxication and their subjective judgment of how dangerous it would be for them to drive at that time. And they predicted over and above their BAC. a critical thing about this study, and I can talk about this now, or I can talk about it at the conclusion, is we do not let people see their BAC information. I want to emphasize this because I know a lot of people are using these devices. I see several grants on this now. I've talked to the CEO of Backtrack about it. These guys make this device, and their goal for making this device is to help people be safe, right? They're selling it to people who are trying to limit their drinking or make better decisions about their drinking and driving, or to track their obtained BAC. That's great. But I've brought my breathalyzer to bars, right? It's actually kind of fun, right? If you bring a breathalyzer to a bar, two things happen whenever you do that. One, just about everyone in the bar is going to come up to you at some point and ask to blow in the breathalyzer. So I always bring a lot of extra mouthpieces, right? The other thing that will happen is some group of individuals, usually young males, will blow in the breathalyzer, will look at what their BAC is, and then say, I can do better than that, I'll be back, right? So BAC feedback, in the absence of any motivation or in the absence of any other stipulations, is one of the only iatrogenic interventions we've ever developed for college student drinking, right? Telling someone what their BAC is with no other stipulations around it challenges some subset of participants to see how high they can get their BAC. So the off-the-shelf app gamifies their BAC readings. Guess what your BAC is? Oh, here's what it is. This is what it means. And for some people, that is very effective at keeping them safe. But as a researcher, I was not comfortable with giving 21 to 25-year-old heavy drinkers that information in real time, because I could not guarantee that some of them would not see how high they can get their BAC, right? But what we can do, so anyway, with the computer scientists, we integrated the device into the app. And what that means is we now have control of that information. So the device connects directly to TigerAware, which is the application that we use. TigerAware then conditions the next question on what your BAC is. So it never reveals your BAC, it records it, but we can deliver warnings to individuals based on what their BAC is. So what we've done for the first study is very simple. We give them a warning if they're above a set BAC. I'm actually not going to say what that is, but it's not the legal limit, right? It's quite a bit below the legal limit, but we do not tell our participants what it is either. But it's a limit where it's not safe for them to drive. We're not lying to them, right? And say, hey, your BAC is pretty high. You should not drive. Here are some links to seek an alternative ride home. We have had participants come back and say, this really changed the way I think about my decision-making. And that's very gratifying to me. We're still in the field. COVID disrupted things. COVID disrupted things. So we're still in the field. We don't have an answer to whether this nudges people essentially to change their decision-making about their driving. But we're hopeful it will. And I'll talk a little bit about what I consider future directions for this. But I think at least that simple information is an interesting question of whether that alters their intentions, the behavior, or the link between those. You know, after someone gets a warning, does that increase their perceived risk? Does that say, oh, I didn't realize I was this drunk. I must be more drunk than I thought. So I have a lot of ideas about how to make this more interesting and more complicated, but I'll talk about that a little bit. So we're in the middle of that study. I want to switch gears for a little bit and talk about my decision-making research. And then at the end, I'll kind of try and bring several of these threads together. So in collaboration with Clint Davis Stover in my department, who's a decision researcher, I am trying to study the process by which people make decisions. And working with Clint over the last 10 years has been really eye-opening for me in terms of modeling, but also in terms of how I think about research. Because before I started working with Clint, I would describe myself as someone that studied how people make decisions about driving, right? But there is an entire literature on the process by which people make decisions and uncovering the decision-making process and strategy that people use for making trade-offs about their decisions. So I want to talk a little bit about that, particularly as it applies to alcohol-impaired driving. So the decision of whether to drive after you started drinking, right, is complicated. And it can involve a lot of steps and a lot of options, right? You could decide before you go out to take preparatory steps, appoint a designated driver, You can take a ride to the venue. You can go to a venue that doesn't require driving, right? Or you could take lots of steps. So it's complicated. But in the end, every time someone drives when they're impaired, they have decided to drive when they're impaired, right? So they might have not driven when they're impaired for lots of different decision points. But in the end, you either drive impaired or you do something else. And so we developed a general structure for testing the way that people make that trade-off at the simplest level. So what we did was we created an index of the number of drinks that people have in a 2-hour period. Then we did a couple different things. I'm just going to talk about the cost version, but we asked people, you've had this many drinks, would you drive yourself home or would you take an alternative ride, right? And we stipulated it could be a taxi, it could be Uber, but we gave them variable costs associated with that ride. So anywhere from $5 to $30, right? We also looked at time, and I can go into that if people want, but I'm not going to present the data on that. We then modeled how people make the trade-offs between how many drinks they have and how much a ride would cost and how they make the decision about whether to drive or not. So this is what the task looks like, right? You've had one alcoholic drink the instructions, stipulate the time frame. Do you drive, which we're stipulating again, not 100% accurately, is free, or do you take a ride that costs $25? You've had 2 drinks, how do you make that same decision? You've had 4 drinks, how do you make that same decision? Then we go through every other pair. We reduce the ride cost, we increase the ride cost, we change the ride cost as a function of the different number of alcoholic drinks that they've had. Okay, so relatively simple. But what we do is do hierarchical Bayesian modeling to look at the changes in their choice probability. What's the likelihood that they would pick riding or driving themselves home? And we can generally classify people into 2 different types of strategies, right? We have 2 variables essentially, right? How much it costs for a ride and how much you've had to drink. And a compensatory strategy would incorporate both parameters, or another way of putting it, in order to understand all their choices, you need a 2-parameter model, right? You need one that includes both cost and time. So they're trading off, cost and drinks. So they're trading off how many drinks they had with how much it cost. Or a non-compensatory strategy, which I'm going to talk about in terms of number of drinks, but non-compensatory could be either where they ignore one piece of information and they focus on the other for some subset of their decisions. And we compare that to an unconstrained model. And we classified them by largest Bayes factor. In this study, we did 2 different studies actually. We pretty routinely find about 75 to 85% of people can be classified as using one of these 2 strategies. Maybe eventually we can classify the remaining 20%, or maybe 20% is just the people that get really bored because it's a pretty long task, to be honest with you. But 80% of people can be classified as pretty consistently using one of these 2 strategies. This is a depiction of 2 people hypothetically, right, using the 2 strategies. So non-compensatory is pretty straightforward. The only parameter we need to understand this person's costs, decisions across all costs, is the number of drinks, right? They don't change their decision-making as the cost of the ride goes up. However, the blue person, the compensatory person, is starting out saying, well, if I had 3 drinks and it was a cheap ride, I would take the ride. But as the cost of the ride goes up, they are willing to drive themselves home at higher number of drinks. Eventually they plateau, right? But that's not till 6 drinks. So this person is engaging in a strategy where they say, I'm going to look at both how much it costs and how much I've had to drink in deciding whether to do this. Similarly, here's a little bit more complicated. The first person is considered non-compensatory, the red, because at 1 drink, very cheap ride, they'll take it. After 2 drinks, they start to change to a ride, but eventually they just plateau out and they say, after 2 drinks, don't even tell me how much the ride costs. Where the other person is always looking at how much the ride costs and makes in the moment changes in terms of how many drinks before they are willing to accept a ride based on the cost of the ride. So hopefully that makes sense to everybody. What we found was that compensatory decision makers are more likely to report drinking and driving. It's kind of obvious in the way of thinking about it. If someone says, I've had a lot, I think I should consider a ride, but tell me how much the ride costs. That's an important factor in my decision. That is more likely to lead to poor decision-making about whether they should take a ride or drive themselves home. So we found in both studies that compensatory decision makers reported more alcohol-impaired driving, and it predicted frequency of alcohol-impaired driving over some similar perceptions, like how many drinks do you feel like it's safe for you to drink and still drive home. So it taught us something that we weren't getting from our normal models. So cast this way, compensatory decision making, which typically is a pretty sensible thing, right? Looking at all the factors that could play out in a decision making situation. We don't want people to do that for alcohol impaired driving, right? Those strategies are more associated with alcohol impaired driving than non-compensatory strategies. Another way of thinking about this is the safer way to think about alcohol impaired driving is rule-based decision making. The rule being how many drinks you've had, and that's the only thing you focus on. And another way of thinking about that is that that might be what has been so effective about the per se limit. We have a law that says when you're 0.08, it is statutorily illegal for you to operate a motor vehicle. And it encourages people to think, am I at or below that limit or not? And people that use a strategy consistent with that are reporting less drinking and driving. So that was interesting. But of course, tying it together with the first set of studies I talked about, people don't make that decision when they're sober. The decision, the way we're casting it, is something that people decide when they're intoxicated. Excuse me, get a quick drink. So we did a lab study. This is one of the last lab studies before my alcohol administration lab shut down for a little while. We tested whether being intoxicated affected this and whether there were acute tolerance effects or whether there were differences in decision-making strategy on the ascending and descending limb and whether those differences matter. So we did the same task. I want to be clear that we did a hypothetical amount. I'll come back to that. And we had people complete the task at 0.071 pretty exactly on the ascending and the descending limb of the blood alcohol curve. Again, we were able to classify about 75% of the people. We found a lot of people actually switch strategies. So it wasn't such a thing that people use the same strategy all the time. People switch strategies from the ascending to descending limb, but there was no clear pattern in that people were more likely to be compensatory or non-compensatory on the descending limb. But what was clear was that the strategy they used was still associated with in the moment decision-making variables, including subjective intoxication, attitudes, and intentions about alcohol impaired driving. So this paper, I should say, is done by Sarah McMullen, who is a postdoc as part of our program, working primarily with Clinton Davis Stover, but also with MISA. So this slide, the lowest line is the one you should be looking at, right? Those are people who are non-compensatory on the ascending limb, but switch to a compensatory strategy on the descending limb. They were different compared to all the other groups. And they were different in that they saw drinking and driving as less dangerous, and they perceived themselves to be less intoxicated, again, at equal intoxication levels compared to other people. So it's starting to suggest that their decision-making strategy only really matters on the descending limb. We also have this when we look at their judgments about whether they would drive. There's a little bit of evidence here that being compensatory on the ascending limb, that's the first bar, does matter. So they're compensatory in the ascending and the descending. Those guys were willing to drive at higher BACs than others, but the highest were people that switched to a compensatory strategy on the descending limb. And that was the only one that was significantly different from the other two groups. Okay, so this decision-making strategy, I'll wrap this part up, was associated with alcohol-impaired driving, and our lab study showed that it was associated with risk variables and intentions for alcohol-impaired driving. Strategy use under under intoxication did matter, but really only on the descending limb. And this line of research, I have a lot of ideas about this line of research, but it does make me start to wonder about how can we get people to do more rule-based decision-making in terms of their drinking and driving. Of course, that's what the per se law is supposed to do. But within people that use the rule, can we improve the rule? And then for those of you who are interested in alcohol-impaired driving or impaired driving, cannabis is the new frontier. We are scrambling right now to figure out what the rule should be for cannabis. And can we mimic some of the success we've had for alcohol-impaired driving for cannabis-impaired driving? That gets really complicated. I'm happy to answer questions about it, but we're never going to have something like BAC. So we're not going to have something as clear for cannabis as we do for alcohol. So overall, right, I've shown that studies both in the lab and AMA can give us insight into the process by which people make decisions, risk variables such as attitudes and intentions, that mobile tech opens up new avenues for studying this and testing some of the hypotheses we all like to test in our labs, but looking at studying it and changing it in real time. And that decision modeling can identify meaningful differences in how people appraise risk and the process by which they make decisions about risk. I want to just mention before we turn to questions, the things I'm working on right now. I alluded to this, but of course I want to look at some of the processes by which contextual information, where you're drinking, who you're drinking with, what time of day you're drinking, how that moderates the process by which people make alcohol-impaired driving decisions. I'm very interested in that. I also want to model acute tolerance in the natural environment. I alluded to this earlier. And so I have a grant submission and a paper on this. The idea is, like I said, maybe the descending limb doesn't really exist psychologically and people are asleep for most of it, but also the descending limb, people make decisions about ongoing drinking based on the intoxication and the subjective states they're experiencing, right? Can we model how people make decisions, not just about whether they should drive or not, but whether they should continue drinking based on the experiences they're having while they're intoxicated, right? People drink to achieve a certain state. Can we model that? Can we understand that? And can we develop a model of risk that it better approximates the way people actually drink in the natural environment? The decision-making task that I mentioned is really interesting, but we're revising it now, and the reviewers really don't like the fact that we still used hypothetical drink amounts, even though people were intoxicated. I don't like it either. The problem is the math that underlies this model doesn't really tolerate how drunk you are or your BAC being a random variable very easily. I think we've developed a model to extend this so that we can plug in, instead of you've had 4 drinks, what your actual BAC is, right? So we don't even ask them a question, we just measure their actual BAC. If we can get that model working, which we're pretty close, then we can adapt it to actually doing that decision modeling in real context using EMA. It's a pretty simple task. We can get people to fill that out and look at how people make those trade-offs and whether they're related to their actual decision that day. And I'm very interested in expanding on the warning labels that I've talked about. One of my ideas is to provide that information about what their BAC is in a way that can't be used to increase risk, whether it's red, green, yellow, right? So not a simple you're too drunk or you're fine, but a red, green, yellow sort of information, or actually harnessing social context. One of my ideas for R34 I'm working on is to have people sign up for a designated driver program where they actually get text about their designated driver's BAC, right? You're designated because there's good research that 25 to even 50% of designated drivers drink, right? They say, oh yeah, I'm the designated driver. But a lot of times they're just trying to drink less than their friends, right? And are they making a good decision about who drank the least? So using BAC information to help them make a better decision about that, and maybe at the end, pick who the right person to be the designated driver, which might be nobody. So I'm very interested in that direction for my work. So that's my last slide. I want to mention my collaborators, some of whom I've talked about Clinton Davis-Stover, Ken Scher, Tim Truel. Yi Shang is our computer person. Bruce Bartholow also works with me on this. Sarah Peterson, I continue to collaborate at the University of Pittsburgh. Michael Amlung, I'm not sure what university he's at now, but then my postdocs and graduate students that also helped me prepare this research, and NIAAA for their support. And nobody other than the federal government ever gives me any money, so I have no conflicts or disclosures to report.
Thank you very much, Dennis. I get some flack for having previous training at Mizzou now that I'm at KU, so I hear that
sure
as well.
You do.
Yes. So we have time for a few questions they've been put in the chat, one of which was from Bruce Lees. He asked a really good one, but he actually had to step away, but he's going to watch the recording. He's asking, when it comes to people with alcohol use disorder, you know, there are ethical reasons why it's difficult to do alcohol administration studies in those contexts, but he's wondering if the results would be different if people that have meet criteria for an alcohol use disorder, and would it even be the case that they might be even more likely to say that they're willing to drive because of previous experience, you know, in terms of their perceived impairment?
Yeah, this is a great question. So I will point you to a recent paper by Sherry McKee and Walter Roberts, that they are arguing that we should, this is such an important issue, that we should actually tolerate treatment-seeking AUD people being enrolled in alcohol administration studies. That excluding those people from alcohol administration studies has so biased our understanding of this, right? Because we know how much your brain and your subjective experience changes as a function of how much you're drinking. And to exclude that end of the distribution has biased this type of work, right? And so they have a really good paper kind of cogently arguing it. The ethics get complicated, right? But I think the more your body has adjusted to alcohol, the more dependent, you know, to use an old term, the more dependent you are on alcohol, the more the acute effects of alcohol are going to play a very different role in your judgments, right? That's part of why it's a disorder. But we don't have a lot of information on that.
Great. And the next question is from Sarah Bibler. She's interested if you could talk a little about the participants in your study. So about their age range, financial stability, drinking patterns, and obviously a lot of the things you're talking about have financial implications. So how does that play into this?
Yeah, good question. So I'll answer it in a couple of ways. I don't talk a lot about the participant distribution, but pretty much I always limit it to legal drinkers because I don't want to get, you know, obviously the lab that's required. But even in EMA, I could do those studies with underage individuals. But then even enrolling in my study to some extent is admission of you know, minor in possession rule. And so I look at people 21. If I'm doing driving research, ideally, I limit it to 21 to 25 because that are the peak years of alcohol impaired driving. But a lot of times I do 21 to 29 just to kind of a little bit of a broader range. We don't limit it to college students, so we do not recruit primarily on the Mizzou campus. But as I'm sure is true in Lawrence, if you get 21 to 29-year-olds in Columbia, Missouri, a lot of them are students. The one question about socioeconomic status. So by and large, how much money you have affecting your decision about driving it doesn't really impact it, even though it should, right? Can I afford a DUI? Can I afford a lawyer to get me off a DUI? That doesn't seem to factor into people's decision-making. But the decision-making task is about money, right? And so a $25 ride means something different for people at certain income levels and others. But as is true for a lot of behavioral economic research, income level did not relate to either strategy or the mechanism people use to make those trade-offs. I will say, because you've alluded to this in both of these questions to some extent, I think that part of what happens in the process by which people make alcohol impaired driving decisions is they don't get caught, right? We know that less than 1% of the alcohol impaired driving episodes, when people drive above the legal limit, less than 1% of the time do people either get in an accident or arrested. And so I think people get a very biased feedback process. People with alcohol use disorder certainly do, but people who maybe are trying to save money also get biased feedback that this is not as dangerous as I was led to believe, or I couldn't have been that drunk because I drove home safely and I didn't get arrested. but we're talking about less than 1% of the impaired driving episodes leading to either of those things, which makes it sound like maybe it's not that dangerous. I want to be super clear. It's still a 20 or 30-fold increase over driving the same distance sober in terms of fatal accident risk, right? So it's a huge increase, but still in terms of probabilities, it's really low. And people are really bad at judging those probabilities.
Great. I will mention for our colleagues at KU, Dennis was going to come face-to-face for a couple days to visit, but we couldn't make it happen because of COVID. He is going to be coming in the spring. We're going to try and work something out. So a lot of these questions will have a chance for you to meet with him one-on-one. I want to go to our Q&A section here for a question from Carly Sloan. She's asking about rural versus urban context or backgrounds. So folks from rural backgrounds may not have access to public transportation or ride services like Uber and maybe have different social norms. So how do you think that plays a role?
Yeah, this is a great question, right? Unfortunately, the data on rural versus urban risk for drinking and driving doesn't show the pattern that you would think, right? You would think that driving intoxicated is riskier or more likely in rural settings because you have more options in urban settings. It doesn't always work out that way, but I think it does work out when you compare certain rural versus urban, right? So like DC, I think they find less because the public transport system is so good, right? And so accessible and so heavily used, where other cities like St. Louis don't necessarily have that, right? Not going to pick on Kansas City. But so that's one issue. But the other issue, I have another grant where we're looking at this also with breathalyzers, where we're trying to recruit more broadly, and we don't have a laboratory study, so we can get some rural versus urban comparisons. Obviously, people in rural areas have less options. It does not seem to universally, when you compare rural versus urban, to lead to more drinking and driving. But in a lot of cases, it does, right? So when we just do a rural versus urban comparison, it doesn't. But I think a lot of times people don't have options. That's not maybe a great answer to that question. I apologize.
Okay, in the interest of time, I think we only have time for maybe one or two quick more questions, and I have to be selective here. We did get a lot of really good questions, but I want to go to Ali Brenman's question. So you mentioned earlier that there's problems with the language around drunk driving or driving under the influence, and why do you think alcohol-impaired driving is more appropriate?
Yeah, good question. Well, so drunk driving, I don't like, because it implies that driving is only a problem when you're drunk, right? And NHTSA has recognized this. They have their buzz driving as drunk driving. And I'm like, well, then why say drunk driving, right? So the implication that driving after drinking is only a problem when you are drunk is problematic, right? So I would be okay with buzz driving, but drinking and driving, and I literally have had people have this confusion, implies that you're doing them both at the same time. And obviously that doesn't matter. It's much more about that. So I would be okay with something like buzz driving, but any impairment by alcohol, it makes it unsafe to drive, right? And 0.05, I don't want to get into weeds because we're running out of time. I think that there is a value to people knowing what their BACs feel like. When I have friends that have never used this before and they drink some alcohol and they blow in a breathalyzer, they're shocked at what 0.06, 0.07 feels like, right? That they're technically legal to drive. And so, yeah, so I'll end with that.
Okay, and then I did see a series of really excellent questions from Tara here, but I'm going to hold those to when Dennis visits in person. But I want to finish with one question from Dave Jamalowitz here. He's asking, do any of the participants in your decision-making tasks or any of your other studies really have prior DUI arrests or convictions, and maybe 2 or more, and how does that impact their decision strategy or their performance in these tasks?
Yeah, that's a great question. So one of the things that I'm doing in the large EMA study is compiling actual police record for participants, right? So they give consent for us to look on public access databases. The state of Missouri has a very good one. But we don't have that data for me to talk about right now. But everything that we know about the effect of drunk driving arrests and convictions suggests it does not have a big effect, right? By the time someone gets to the part where they're getting arrested for drunk driving, not a lot disrupts their decision making, right? That's why I don't necessarily, it's a very high recidivism behavior. Also, you put the interlocks on people's cars, which eventually, hopefully, will be much cheaper and we can do it more. But you put the interlocks on people's cars, one, they go back to drinking and driving at the same rate that they were doing before you put the interlock on their car, as soon as you take it off. Two, we actually had to, I don't know if people know this, we actually had to have the interlocks program to repeatedly ask them to blow, right? Because originally they were blow to start the car. And so people would have a random person blow and then they would drive, right? And now you have to blow every 15 to 20 minutes. It depends on the state in order to do that. So I think from a psychologist standpoint, by the time you get to recidivist DUI, they're not changing their views on this. And we have to be thinking about that group. I'm talking about, you know, if you think, if this is the last question, I'll take a broad step back. We have a really good reason for setting a per se limit, right? It's been hugely effective. We have the technology to tell people what their limit is, to tell people what their BAC is. We're not doing it because we don't know that people will use that information safely, but we could come up with technological ways of whether it's improved interlock devices, right? Or improved feedback mechanisms that don't challenge someone to see how high their BAC can get, but do tell them, and again, their friends, take this person's keys away after they blow in a breathalyzer. I think doing that early in someone's drinking and driving career, if you want to talk about it that way, is the way that we can reduce this. Getting them once they've been arrested, they tend to be a hardcore person that might have done it 50 to 100 times. And that conditioning is so ingrained. We all know people that speed a lot and then they drive away from a speeding ticket because they think, what's the chances of me getting a ticket again today? I think there's good evidence that people do that as soon as they get off their drinking and driving. Well, I did it 100 times before I got arrested. I have 100 more to go. So classic gambler's fallacy, right? So I think there's a lot of that. And so I deliberately focus my research not on recidivists because I would like, as a psychologist, to disrupt these learning processes earlier.
Okay, so with that, we will have to wrap it up for today. I want to thank Dr. McCarthy for a great talk today. Lots of interest in the chat and on the Q&A. Unfortunately, we didn't have time to get to all of the questions, as is usually the case. We did put the link to our events page on our website in the chat. Check that out. We do have one more seminar series for this fall. It is Dr. Elise Wirtz from Johns Hopkins University will be our speaker for November. And then stay tuned for the list for the upcoming spring semester, including Dr. Brian Borsari, as well as some of our colleagues who do more alcohol research and somebody coming to talk to us about the opioid epidemic and relapse prevention and the efforts that are happening in Missouri at this time. So with that, I want to thank Dennis and everyone else on the call today, and we hope you have a wonderful day.
Thanks, everyone, for your attention.